Welcome to video 8 in a series of introductory videos for InventorCAM. This video's topic is 2D iMachining. So the iMachining toolpaths from InventorCAM are our proprietary optimization toolpaths, and they come in two types, one for pocketing and one for target recognition. In this case, the pocketing one, 2D iMachining, is what we're going to cover in this video, and it uses the same sort of functionality and parameters as you saw in the pocketing toolpath in video 5. So let's take a look at it. So just going to open up our CAM part definition, because first thing we got to do is add some material and machine definitions. What this does is it allows InventorCAM iMachining to figure out what the maximum possible speeds for this machine are and how hard we can machine this material. So we need to give that information. In the iMachining data section, you can see that there are some machines that come with the software. There's maybe about 2 or 3 that come with the software, depending on your copy and where you got your InventorCAM from. But generally, those are for trial and training purposes. The objective here is to actually plug in information specific to your machine. So we'll do that in a second. Likewise, for the material, you can see that there's a whole list here of materials that come for training and trial purposes, and they have generic names. It's best to put in specific information about the material that you are machining yourself. So let's get to that website there. So Database Manager is under Edit iMachining Database, and it pops open this window here. And what you'll do is you'll actually type in information about your machines. You can see I have a couple of them in here, and all you got to do is just click on New Machine. And then what it does is it allows you to rename the machine. So in this case, I called this one Test. You can call it whatever you want. Let me just call it Test 000. And the information you need to provide for a machine definition is the maximum spindle speed, maximum feed rate, and the maximum horsepower of your spindle. So this is to know what the maximum limits of your machine are so that we can maximize the toolpath, optimize the toolpath. Likewise, for the material, you can just right-click on any one of these and say New Material. And then from there, give it a name. I'll call this one Test M. And the highlighted information is all you need to provide. Again, in this case, it is the ultimate tensile strength. Both sets of information for your machine and material can be obtained from your suppliers. Your machine supplier has the information about your machine. Your material supplier has the material information. If you can't find any of this information, you should be able to go on the web and find it. Most machine suppliers' websites have data sheets on their machines, and material information can be found from generic material websites. One such website that we usually direct people to is matweb.com. So in this library here, you can just type in whatever information you have about your machine. In this case, I've typed in 4140. Do a quick search, and you can see that from the search results, you find whatever currently matches the material that you're machining. And then in those search results, let's say we just choose this one. You go to your mechanical properties, and you find the ultimate tensile strength of your material. In our case, I did a search earlier for a grade of 4041 that I was machining. And if we look at that definition, it basically said that it has the ultimate tensile strength of what I read from MatWeb. Now that we have our material definition selected, let's go back to the main window. We can add the 2D iMachining toolpath. So I'll just right-click, Add Milling Operation, 2D iMachining. So 2D iMachining, because it works off of the geometry itself, you can choose it in 4 different modes. Now, we've added a lot of recognition to this toolpath, so they actually have different ways of recognizing the part. The first one is you simply select the faces. So if I want to machine this bottom pocket, I'll just click on the bottom face of that pocket, and it's recognizing all the outside edges there. It will capture the edge geometry from that. So if you remember from the pocketing video 5, we had to actually either choose the outside edges or we could do a select face. This is similar to select face. So I'm just going to jump ahead. I'm going to grab my tool, and we covered tool selections in video 2. So all these are from just doing those definitions. As soon as I click on my tool, now 2D iMachining is going to recognize, well, this tool can do that geometry like that. You can see that blue profile there. It's letting me know that that's all the material that it's going to recognize, and it can machine. So it's recognizing it to the top of the stock, or in this case, the top of the updated stock, and it notices that there's that internal island. Now, obviously, this won't be the best toolpath. I really shouldn't be leaving that island in the middle, and I've got those tabs on the side there. So let's do this using one of the other features. I'm actually going to do it using the feature recognition by chains. So this is also similar to what we saw on the pocketing side. I'm going to actually choose chains to define this pocket. So I've got my constant Z turned on in that left menu. I'm just going to grab the top edge of the pocket, let it go all the way around using that constant Z relationship. And then as soon as I grab my green check mark here, it's waiting for me to choose my levels. So we'll go down to the levels here, and you can see that it's grayed out the top level because, again, it's going to go all the way up to the top of the stock. So I don't need to select upper level anymore. I just need to go and tell it how deep I want it to go. Now, if I choose this same face, it'll do the same thing as it did with the other recognition. It'll recognize there's an island, some tabs. It'll go around those. But I intend to actually machine the entire pocket just above those tabs. So I'm going to grab this as my lower level, and now it gives me a profile, a preview of what it's about to machine. It's going to just basically fill that area in. So there's a lot of recognition there to avoid gouges, to avoid machining features, but sometimes you got to look at what it is you're selecting and take a look at that. So this is going to machine that entire pocket there. The workflow of 2D iMachining is very similar to pocketing. As we did here, you saw geometry, tool, and levels. Now we need to decide feeds and speeds. Well, with iMachining, feeds and speeds are actually going to be locked out because iMachining is controlling that. It's calculating those based off your machine, your material, and now I've given it the dimensions of my end mill. So all three features, all three bits of information go into the calculation of iMachining. That being said, we can control how aggressive that calculation is, and that's under the Technology Wizard section. This sliding level here is the level of aggressiveness of that calculation. If you see on this representation here, that yellow portion represents the cutting length of our end mill. Cutting length will be used as the depth of cut. So iMachining is going to optimize this toolpath by going full depth of cut, utilizing that entire flute length. In terms of step over will be regulated throughout the toolpath. So there really isn't much control over that either, unless you're controlling the aggressiveness. And again, that's all under this one window. If we take a look at the chip thickness of that red line, that increases or decreases as I slide this back and forth. Okay, so again, we're optimizing the cut, we're controlling the feed, the speed, the cutting angle, the step over, all that stuff throughout the toolpath just to maintain the chip load. Chip load, chip thickness, we're maintaining that as we go through. You notice here that the feeds and speeds also increase or decrease as I slide that back and forth. Again, we're trying to optimize it, getting it as hard and fast as possible while still controlling the toolpath aggressiveness. If there's something here you wanted to take control over, however, you can turn off the wizard, and that gives you control over your feeds and speeds. If you wanted to control the step down, so instead of using the full flute length, I can switch this to user defined and control it by number of steps, or actually give it a step down value. If we go to technology, you'll see that the step down is under our control. But again, if I turn off the wizard, we take control over the step down and the cutting angles. But with it all calculated for me, all I have to do here is make sure that I'm machining whatever I'm looking for. So in this case, I'm trying to do roughing. I can check the box here and I can say leave 10 thou on the walls and the floor. So for this toolpath, we'll just leave it at 10 thou. I'm just going to do a save and calculate. We'll take a look at the toolpath. It is a pocketing toolpath, but it follows a different strategy than pocketing. It's going to use a tricoidal toolpath. So by default, iMachining uses a helical entry, which we saw go into the part, and it begins a morphing spiral from there. So as much as it can, it will keep that spiral going as it goes across the pocket. But obviously, it can't keep that spiral along the pocket because the shape of the pocket doesn't exactly match. So once it gets to these corners, it actually uses a D-slot tricoidal. It works its way into the corner, maintaining that material engagement, maintaining that control over the tool so that it doesn't overwork the tool, overbury the tool. And that's why you don't actually see any right angles here. There's no offsets don't lead to sharp corners where you hear the squealing. It will always make sure the cutting angle stays between 10 and 80 degrees or less, depending on the combination of the machine, the material, and the tool dimensions. And it'll make sure that the tool is not overworked. We essentially think of this as cutting in a straight line because that spiral is constantly engaging the material. You'll also notice that there is actually no real rapid movements. There's really just one entry, one exit. All the rapids are contained inside the pocket because it already knows that that material has been removed. So there's no need to actually exit the part to reposition itself. So we're reducing cycle time at the same time as we're controlling the material engagement and improving the tool life. So let's get out of this pocket and let's do another one. So I'm actually reopening it. I'm going to do a save and copy. So we can use the same tool. We're just going to do it on the bottom pocket now. And we'll use that previous recognition that we were looking at before. I just need to choose the bottom face. Now in this case though, if we take a look at the profile, it should be recognizing as soon as I do a save and calculate that we already machined that pocket. Okay, so let's get out of here. And you can see that it's working its way only on that bottom area there. It's recognizing all that, all the edges that we captured from there. It still does the helical entry. And you can see that there's some additional movements inside the toolpath. Let's just get a top view of that. This is called the separation channel. So if it cannot do the morphing spiral that you see it trying to do over here, it will just do a morphing spiral. It'll wiggle its way through there and work on the material. Now what I want to show you with this particular toolpath is not only does 2D iMachining do roughing, but it can do finishing as well. Now you could separate this out to a separate pocketing toolpath or profile toolpath just to do the finishing, but if you're already inside of iMachining and you want to use the same tool, you can switch it from the iRough to the iFinish. And then once you get to the technology section, you get some finishing parameters as well, one of which is the floor. And we give you the option to use contour flooring as well, only because if you take a look at the iMachining, that's not going to be a good finish. It's going to be accurate dimensionally. It'll remove all the material, and it's still iMachining, so it controls everything. But those arc movements there probably don't leave a good finish. So what we could do is leave 10 thou behind, and then we can do an iFinish to clean up the floor. And because we're using contour style, it will leave a contour style similar to what you would have seen with a pocketing toolpath. And you can kind of see that if we zoom in. Now, let's take a look at some of the other options inside of SolidCAM's 2D iMachining. So I'm going back to the original pocket, and I didn't mention it, but there is actually this little floating window here, and that is because we have it set to Multitool. This exists in both the 2D and the 3D versions of iMachining. And the reason Multitool is here is if we go to the tool table, I can actually add multiple tools and they auto-generate what's called the rest operations. There is a separate iRest operation here, which would require me to do a save and copy, which is what we would have done in previous versions of InventorCAM. But because we have Multitool, now we can add as many tools as we need and step down the diameters so that they do automatic rest operations. For instance, let's say we already got the 1 inch. Let's go and select our 1/4 inch tool. So in this geometry for this pocket, I'm applying 2 tools. We already looked at what we were going to do for the 1 inch tool. We have it set to level 8, and we're leaving that much material and so forth. If I go back to the technology section and select the second tool, you can see that it's giving me different parameters. I'm just going to tell that also to be revved up to level 8, and this guy is set to iRest against whatever the first one did, the 1 inch. So if I do a save and calculate on this, it actually will generate 2 2D iMachinings, one for the 1 inch and one for the 1/4 inch. And that's simply an automatic rest operation. It's going to recognize that the 1 inch tool could not do the corners and go ahead and do those for us. So that's basically what that is right there. All those corners are now being addressed by the second 2D iMachining that was generated there. If I needed to, I could actually set it up as a separate iRest simply by doing the same sort of thing. I can open up the toolpath, do a save and copy, and then switch it to iRest. Now, I wanted to show you some of the last couple of ones here. Let me just do a save and calculate on this guy so we can have this up to date. And then the 3rd and 4th modes of geometry. Let's address the outside material. So I have my stock hidden at the moment, but there is a stock outside the part that needs to be removed. So let's go add 2D iMachining. And we'll use the third option. The third option is not actually asking you for any geometry. That is because that is everything on the outside of the part. So if we have a proper stock and target definition, we know how much material on the outside exists. All we have to do is let SolidCAM take a look at that and machine that for us. So as soon as I choose my tool, let's say we just go back to that 1-inch tool, the preview is going to be everything on the outside of the part. So that's based off of the stock and target definition. The rest of this, I just let it read from the part. So let's say that is the full depth of the pocket. I could go ahead and click on the bottom edge if I wanted to tell it to do all that. But again, there's a lot of recognition there, so I'm just going to leave it as is. We'll do a save and calculate. And it gives us a toolpath for the outside of the part. When iMachining goes into a cavity, it does the helical entry. But if it can do side entry, like it has with the outside part here, or if there's any open chains that you define in your geometry, it simply does a side entry like you see on this window here. I'll reopen that last one just to highlight the fourth option. Fourth option basically works the same way as a traditional pocketing toolpath. You just choose some chains and you set your levels. How that's different from this chain selection is this one is automatically going to recognize all the nearby material. It'll extend your chain outwards. You can actually use open chains, and it'll extend the profile of the machining toolpath outwards. So it's a good way to allow the recognition to help you with open chains or sides, open pockets, anything like that. Any questions of this or anything else from InventorCAM, just give us a call at 1-866-975-1115 extension 2. You can send us your parts or your questions via the ticket system at solidcamsupport.com. And stay tuned for the rest of the videos on this YouTube channel. Thanks for watching.